Hi, I'm Martin, and I'm currently working as a web developer for the last 12 years or something. But I studied originally computer engineering, which is quite a different field and has a lot to do with electronics and all that. So I'm really got into all this hardware hacking stuff when it came up recently. So yes, I love home automation, and I love that idea. Like in Star Trek, I enter my home, and it suddenly just wakes up, and there is a light setting, and I can say, "Computer, play jazz," and jazz is turning up, and all that is actually possible now. So. I can buy all that stuff. That can help me to make my home just as I always dreamed of. So let's have a look. There are currently turning up all the things like smart light bulbs. This, for instance, Philips Hue lights. Osram has some. General Electric built some, and there are several more vendors jumping on the train. But the problem with all this is you have an app. You can pick the colors of your light. You can pick the brightness and all this from your smartphone, and even when you're not home. But why would I want to do that? But anyway, the problem with this is it is just terribly expensive. They charge you around 50 euro for a single light bulb, and then calculate how many of them you need in your home. This is not something that is worth the money in my eyes. Then there's lots of other smart home stuff. We have remote-controlled power sockets, for instance. There are switches that can control other things, and we can control our window blinds, radiators, and all that could be all done automatically. And also controlled from an iPad when you're not at home, which probably makes more sense to turn off the radiators when you're not home. But yeah, so all that is there, and there are actually quite a lot of standards not compatible with one another, and there are a lot of vendors who simply ignore them. So if you start buying these things, you pretty much stick with one vendor, and yes, they charge you big time. But yeah, there is hope. And because nothing these things do is anything magic, actually. So it's really just simple electronics. So I started to try to build some home automation tools myself, and for really just a fraction of the money I would spend on the commercial products. And I'm going to show you how. So first of all, I will give you a brief introduction into small-scale computers like Raspberry Pi, or even smaller scale, that will allow you to program all this and make it communicate and control different aspects, whatever. There will be a really tight introduction into hardware programming, which is something I would guess most of you have not done before. And lastly, I will present my latest completed work, which I completed just the day before yesterday. And it works. So let's get started. Computers and microcontrollers, or MCUs, like they are called. This is kind of a spectrum I picked just 4 different boards at random that probably represent what is best known today. There is, on the left-hand side, you can see the Arduino, which is really, really, really restricted in its resources, just runs on 16 megahertz CPU. And on the other hand side of the spectrum, there's a Raspberry Pi 2, which is a full computer. Pretty much compares to something like a modern smartphone in performance. It can do basically anything you could do with any other regular computer. Still, they are pretty small and quite usable for hardware hacking stuff. So, we have a look there. The Arduino generally is a microcontroller, and it's programmed in C or C++. It just has a USB interface, so it acts as a USB device. I can send data from my computer to it using USB. But it really consumes pretty much no power at all. It can run several weeks from a single battery or something like that. Next up, this is one I'm going to talk a lot about. It's ESP12. This is something that came up just in the last half year something. It's also programmed mostly in C and C++. Some awesome guys from China built a Lua interpreter that runs on it, so I can write my own code using a nice language like Lua. And the key feature of this thing is it costs only €2, and I can just put it into anything that I build, and it's just like that. I can leave it there because I have several more of them. This is not the case for all the other options. If I do something with an Arduino, I want to keep that Arduino. I don't want to put it somewhere in a shelf and let it run there. And the same for basically all the other options, where they are great, really great for prototyping. So the Tesla, I put it here because it's being topic tomorrow in a hardware hacking workshop, if I recall correctly. So you can program it on JavaScript and Python and Rust. It has all the interfaces that you dream of. And yeah, you can do pretty much everything with it. And it's, performance-wise, something in the range of a Wi-Fi router or an older smartphone or something. Yeah, and then there's the Raspberry Pi, which is, like I said, just a computer. So, how can these small devices communicate with others or other electronics? This is something general-purpose I/O. You can see in the picture these GPIO pins. And this is these are the connectors to other electronic devices. You can use them just as simple switches where you can switch voltage on and off, you can use them to communicate with more elaborate protocols that allow you to speak to something like a temperature sensor or stepper motors or anything really. The basic principle is just they have two levels. This is a 0 and 1 thing. 0 means there is 0 voltage, and 1 or high means there is either 3.3 or 5 volts of voltage, depending on what you're doing there. You don't need to worry very much about that because most of the time you just plug some wires together and nothing gets damaged, and so you're pretty safe there. So let's get started. Switching an LED. That image shows a pretty normal representation of how an Arduino project is built. So what you see at the top is something called a breadboard, which is just a small board which has tons of tiny holes in it, and all these tiny holes you can use to plug electric components in. So each of the columns of the breadboard is connected together, so two things and adjacent holes will be electrically connected together, which is symbolized by the green dots there in the image. So what we have here is LED, just something that makes light. We have a resistor. The resistor takes care of not damaging the LED by letting too much current flow through it, and then there are some wires that connect it to the Arduino. Now, if we wire that up, there is some software that we can write for this, and it's really just these 13 lines of code. And so you see in line 4, there is this setup function, which just tells the Arduino to handle the pin number 9, which you can see marked in the image with a red wire. Handle that as an output. Then what Arduino does, it runs the setup function, then runs the loop function, and then runs the loop function, and then runs the loop function all and all over again until it loses power. So there's no operating system, there's nothing else running on that thing, which is quite fascinating about microcontrollers. This is it's just 13 lines of code, and it runs and runs and runs, and if the power is out, then it runs no more, and if you put the power back on, then it runs again. And so this is what I got here. I put the power on, and the only difference is I didn't take one of these tiny LEDs, just something with a little bit more power, but it's still an LED, and it is precisely that program that is running there right now. Next up, we can just speed up this switching on and off and on and off and on and off. We can speed it up quite a bit. If you do that 500 times per second, you will no longer see any blinking or something. You just see there's the light intensity changes. So we can just dim an LED just by toggling it on and off at a pattern. What you see there in the image is my oscilloscope, and it actually shows how the LED is getting brighter and darker. And on the left-hand side, you can see the power going off and on and off and on, which repeats 500 times per second. So this should give you an impression of how this works. I will now just quickly... So I now reprogram that Arduino sitting there with that very program that you can see. It is basically just, instead of using the delay function to wait milliseconds of time, we now wait for microseconds of time, which is 1,000th millisecond. And we simply change the time for which the LED is on. And the result is it's just dimming up and down slowly. This, of course, is pretty much useless. It is nice to be playing around with something like that, but you lose interest in about half an hour or something. So let's move on and do something more interesting. External inputs. So what I'm doing next, I already did that here. I have this small knob which I can turn, called the potentiometer. And this will allow me to regulate the light intensity by just taking the value from that potentiometer and feeding it into my program to regulate how long this thing is running. There's a syntax error. Wait a second. So uploading. All right, it's done. So if I now turn this knob here, I have a perfectly working dimmer. And yeah, if this Arduino weren't costing 25 euro, I could put that actually into a wall or something, and I have my LED dimmable. So this is something you cannot do with most LEDs you buy in a supermarket or anywhere. But yeah, this is basically it about that basic introduction. Let's move on to the ESP12 or ESP8266, which is what the processor in there is called. And this is a really awesome device, simply because it's just so tiny, it's versatile, it can do pretty much everything. It has a CPU that is perfectly capable of running a Lua interpreter, for instance. They are not really that beginner-friendly. As you can see in the picture, there are just these little copper plates where I can solder my wires onto, but you could also buy some starter kit, which is around 8 or 10 euro, which also has these pluggable things that you can just easily connect anything to. So, and in my opinion, this is currently the best option there is to build project that you really want to keep and want to stow away somewhere. So, like I did with my Wi-Fi power strip, this is sitting right there. We'll see it in action soon. What I have here is a board that I made, and it contains quite a lot of stuff. Let's go through it. On the right-hand side, there are the screw terminals. This is where I put the power sockets, which are then being switched on and off. There is that ESP12 module, which I mounted upwards into that thing, so I can put it out and in. And also, because that ESP thing doesn't have any USB connection, I need something, this is programming adapter there, that converts my USB from my PC into a UART serial signal that I can use to program and flash files onto that ESP12. There is a small debugging interface which I can use to just probe around and see if everything works like it should. And yeah, the power supply, which I just ripped apart some 5-volt mobile phone charger and put it back together into that board. Tightly shrink wrapped, so there are no 220 volts part that I could accidentally touch there. And lastly, there are some relays. The relays do the actual switching, and it is basically just relay is a magnetic switch, which is operated by a magnet. You can see it on the right side. There's a magnetic coil, and if power flows through that coil, it creates a magnetic field, which in turn moves that switching contact from the right to the left. And once again, there are some screw contacts where I can just connect my live wires. There is another thing, that's a small transistor. I need that because these tiny ESP modules just can't give very much current, and in order to drive that magnet with it, I need to amplify the signal just a little bit. So, and before I continue, I really need to say that do not in any way mess with live wires unless you know what you are doing, because that could potentially be really dangerous. And yes, so the result, which I have lying around here, is just yeah, it's not really a power strip. It's like a tupper box with wires in it, but yeah, it works. And I don't have to look at it when it's somewhere hidden behind a shelf or something. So, to see it in action, I am right now connected, that thing is connected to the Wi-Fi of my smartphone. And I have a really awesome user interface consisting of 3 checkboxes, which I can now use, hopefully, to switch that light on and off. Or, yeah, it is not limited to lights, of course. And Ola gave me this just to illustrate that you could use it for pretty much everything. So I would have imagined doing that with a coffee maker, for instance. Just have my computer tell it to make coffee at 8 in the morning or something. So how is this programmed? I use it firmware. It is called Node MCU, and it's just feels a bit like Node.js. It is really limited for something for a program that I write. Usually use something around 200 megabytes of RAM or something. This is not possible here, and it runs a Lua interpreter. So this is just the basic parts. So we can connect to a network, which is just two commands. And I wrote a small HTTP library, which feels a bit like Express or something like that, that allows me just basically to switch the relays using this function GPIO write. And this is pretty much the same like we saw on the Arduino example earlier. So, how do you get started? I would recommend, if you really want to do something like that, just start off by buying maybe a Tesla, which is really developer-friendly and doesn't require that much knowledge beforehand, or maybe a Raspberry Pi if you're into Linux. You could do that as well. In order to build some basic examples or something, you'll need something like that breadboard. You need some jumper wires, and of course you need an idea what to do. I would always recommend buying from Chinese sellers because they are just way more cheap than anything else. AliExpress, for instance, is my regular supplier of electronics. And yeah, maybe just because you need a lot of tools to get this going, find people you can do that with, or find a hackerspace near you, and there are quite many. If you look at the Google map from hackerspaces.org, you can see a red area of Germany hidden behind all these pinpoints of hackerspaces. So, and finally, always remember there's no fairy dust involved. It is really just simple electronics. It's just ones and zeros. Thanks.